morning, Internet. I am Matt Buyak, and in this video, we'll take a look at the 31st problem from the Project Euler Problem Archive. Now, this problem asks us to find the number of ways that we can make change using certain denominations of British currency. And the technique that we're going to use to solve this problem is called dynamic programming. Now, I've done a video in the past on dynamic programming and its relationship to recursion and memoization. I'll put a link in the description. I would highly recommend you check that out if you have not already. But just to refresh your memory, roughly speaking, when we're talking about a recursive solution, often we have a function that calls itself. So for example, with this problem, we might have a function that takes an argument for the number of denominations to use. And a key feature is that the recursive solution will call itself with a smaller input size. And so it might call with that number of denominations minus 1. Now, in some cases, the recursive solution will turn out to have an exponential running time. And a typical solution to that problem is to use a technique called memoization, which basically just means that we avoid making the same call with the same arguments multiple times, and we keep a table to cache our results. And often that can take an exponential running time solution and turn it into a linear time solution. Now, dynamic programming can be thought of as recursion with memoization, but working from the bottom up rather than the top down. That is, rather than thinking of it as function calls with caching, we're starting with just the table and we're filling in the table in a particular way so that each entry depends on an entry that's already been filled in. Now, often when we're writing a dynamic programming solution, it can be helpful to first write out a sketch of how that recursion would work. And so that's how we're going to begin. So let's get into it. As usual, we'll copy our template directory to make our problem directory and open our main.cpp. As I mentioned, we're just going to do write a few quick notes here as to how our recursion is going to work. So let's suppose we have our table, call it T, and it's going to take arguments P and D for the number of pence, and the D for the number of denominations that we're using. And so we want to find a way of defining our solution in terms of a solution with fewer denominations. So first, I think we should just note that if we only have one denomination and that denomination is the 1 pence coin, there's going to be exactly one solution regardless of the value P. That is, whether you have 50 pence or 1,000,000 pence, if you're only using the 1 pence coin, it's just going to be a big pile of 1 pence coins. There's only one possible solution. So we're going to define this recursion piecewise. So we'll say it's going to be equal to 1 if D is equal to 0. We're just going to use a zero-indexed array of our denominators here, and so we'll say D equals 0 is going to correspond to the 1 pence coin. Okay, so now let's consider the case where D is greater than 1. So we need some way of determining the number of ways of making change with D denominations in terms of d-1 denominations. And so just to make it a little bit more concrete, let's suppose we're working with the 1 pence, 2 pence, 5 pence, and 10 pence coins. And we're trying to write our solution for making change with those coins. We might observe that, that we can sort our denominations from the smallest denomination, 1, all the way up to, in this case, the largest is 10. And we'll note that the only way that we can make change using those coins is to either, if we're using the 10 pence coin, we're going to have at least one of them. And if we're not, then we just look at our solution for ways to make change with 1, 2, and 5. That is, we're going to split it into 2 cases. If we are using the 10 pence coin, at least one of them, then we can just subtract 10 from our pence value and look at the ways of making change for that amount. Or if we're not using the 10 pence coin, then we can just look at the ways of making p pence of change using the coins 1, 2, and 5. So let's be a little bit more explicit about this. So this is going to be equal to, in the first case, we're not using the 10 pence coin or the D denomination coin, and so we're just going to say that this is equal to p comma d-1 plus p minus denominations d-1. Actually, no. In this case, we have to be a little bit careful because we might be using, if, going back to our example, we're using the 10 pence coin, we might be using more than one of them. And so in this case, we're reducing the amount, but we're not reducing the denomination. Okay, so there's one more case that we have to consider here, which is if our pence value is less than the current denomination, then it's just going to be t of p d-1 if p is less than denominations d. Okay, so that's a rough outline of how our recursion might look. Now we're basically going to build up the same table, T, except we're, instead of using recursion, we're just going to fill out the table one denomination at a time. And so let's have some indices, I and j. And we need our denominations. There are going to be 8 of them. Actually, let's say num denom. And that's going to be 1, 2, 5, 10, 20, 50, 100, and 200 pence. Okay. And let's create an array here to hold our dynamic programming solution. So we'll say uint32t t, and that's going to have 201 values. You'll notice that we need both the 0 and 200 entries. And so in order to get the entry for index 200, you need 201 slots. Okay, So let's go from I is 0 to I up to num denom, increment I. Okay, and then we'll start at let's make a little temporary value here and say denom equals, denom equals denominations of I. And then we'll say, let's see, for j is equal to 0, or no, j is equal to denom. You'll notice that we can't make change involving the denomination denom if our pence amount is less than that, and so we can start at j is equal to denom. Yes, and so then we'll go j is less than or equal to 200 plus j. And then we will say t of j is equal to or plus equals t of j minus denom. And then we just have to be careful to initialize t of 0. Again, this is if we have, if we're trying to make change for 0 pence, there's exactly one way of doing that. So then we just have t of 200. Okay, let's go back to our shell, go into our problem directory, and make. Okay, it appears our solution is 73,682. So let's go back to the archive. And we'll see that that is, in fact, our answer. So that's it for this video. In the next video, I'll be tackling this same problem, but using analysis instead of C++.